we just create a new kernel, blah, blah, blah. In the case of Fuschia, I am sure it started off as an experiment, but it's nowhere near an experiment anymore. It is far beyond an experiment, and we'll talk about that in a bit. So Fuschia is really built on these 4 pillars. If you leave this talk with just 4 pieces of information, it should be these 4 pieces of information. Fuschia is built with security in mind, it's updatable, it's inclusive, and it's pragmatic. Now, secure makes sense, but we'll talk about the security architecture. Updatable also makes a bit of sense. Obviously I want my operating system to update, but we'll also get into exactly what that means. Inclusive and pragmatic, those are very interesting, and I'm going to leave those as mysteries till we get to it. So secure. Fuschia is built on a brand new kernel. It is an early fork of a kernel called Little Kernel. Little Kernel was designed initially, and is still designed for doing stuff on very low memory devices and very low footprint. But Fuschia is by no means limited by that. It is an early fork because the designers of Fuschia, the engineering team, thought that Little Kernel has a lot of good foundations that they can use, and it's open source, the right licensing, whatever. So they forked it very early on, and they started to modify it. Right now, they're very divergent. You can't just send a pull request and merge it. So assume, for all intents and purposes, they're 2 totally different things. The Fuschia kernel is called Zircon, and it's built with security in mind, and it's built to run on all sorts of surfaces. Low devices, as maybe 64 megabyte devices. Don't quote me on that. But then as big servers, Fuschia can run on that. There's no limitation there. And in fact, Fuschia is built as a real-time operating system. If you really think about what that means, I'm not a computer, I'm not an operating system specialist, but from the amount of research I've done, when you look at what a real-time operating system is versus what we have, Mac, Windows, and Linux and stuff, a real-time operating system is really designed with security and process isolation in mind. It's designed to run on spacecrafts and all sorts of stuff, right? So Fuschia is being built with real-time operating system in mind. It is an RTOS inherently. Now, here's where it starts to get very interesting. When we look away from the kernel, we take a look at how applications are built in Fuschia. They're built as container first. Now, this isn't Docker container. You don't have Docker Hub running or anything, but the idea of containers is the most important part of Fuschia. It's when you install an application. Assume I go and install Zoom.us on, say in 5 years, Fuschia is running on a desktop, and I install Zoom.us. Zoom.us will not know anything about the rest of the system. It won't know what other apps are on the system. It will have no idea that anything exists. It is running in an isolated container. The only things that it can access are services that are exposed to it, right? So by default, Fuschia has some services it's exposing. I can assume it's something, in 5 years, it might be something like access to the display driver to draw stuff on the screen. But everything is built with this containerization in mind. If Zoom wants to expose some data to the outside world so that other applications or Fuschia itself can take advantage of that, it needs to expose a service as well. So when I show you how applications are built in Fuschia, we're just going to go through some sample apps, not actually build anything, but just go through it. You'll see how this interface is built. Next, and this is one of the more interesting things, is that a package comes with everything it needs. So what this means is when you build right now, say you talk about Windows, and Windows is famous for this, right? This idea of DLL hell, where you install something and it says it's missing, I don't know, xyz.dll. That's because the application assumes that there is something on the system that it can use. Now, for whatever reason, that version of Windows or something happened that deleted that file that the application needs to run. but now it just won't work. So Fuschia's apps, on the other hand, when you download a Fuschia app and you install it, it is coming with everything it needs to run. It is an isolated container, right? But you might wonder, well, if that's the case, then say you're running a Python app, right? It comes packaged with Python. But if that's the case, what if you have 50 apps that are all using Python? Will you have 50 versions of Python running on your system? Isn't that just going to take up not running, installed on your system? Isn't that just going to take up a lot of storage space? The answer is no, because Fuschia has this really interesting model where it does this cryptographic check for each of the blobs, the binary blobs that are installed with the apps. And it says, well, look, Python has a hash of 001, and another app has Python 2. It also has a hash of 001. So I'm going to take both of them, get rid of one because cryptographically they're identical, and I'm going to move it into the shared blob folder so that the applications know to use that application, to use that blob. This way, you can save a lot of storage space. And if it, say you install Python, say it's an app that uses Python 2.11, for example, that has a different hash, it's not going to reuse that. It's going to use the Python that you installed with the app. So that's how Fuschia keeps everything secure, at the same time managing space and efficiency. Lastly, containers run in their own namespaces. This is very interesting. There is no general file system in Fuschia. So you can't go in a container. Right now, if you're using an app, you can probably navigate in that app to like the root directory of your operating system. In Fuschia, you can't do that. An app only has access to its own file system that it creates. And so if you were to go backslash, thinking that you're going to go all the way to the top of your operating system, that won't happen. You're just going to go straight to where the app is installed, right? So the app thinks that its entire universe is just this container it's running in, the file system it has, the access to blobs, and access to these services that it has. So moving forward, let's talk about updatable. And what does updatable mean? Now, yes, the operating system could update, that's obvious. In fact, the operating system was updated in the most craziest way possible recently, and we'll get into that. But in Fuschia, everything is a component, like the packages and the apps, whatever I'm talking about is a component. Now, here's what's crazy about this. When I say everything, I actually mean absolutely everything. Think about drivers, right? If you're building a driver right now, when you install something on Windows or Mac, oftentimes it says, please restart your computer, right? Because it needs to like reinitialize the driver, whatever happens in the BIOS and the boot up script, however Windows and Mac work. In Fuschia, that itself is a component, and it follows all the principles that all components do. It's containerized, it's exposed through services, blah, blah, blah. What that means is you can swap that out in real time. If you're used to Flutter development, that's called hot restart or hot reload. You can do that with a driver, which is really wild. And how does the driver then talk to any of the applications or the system services? It's through this protocol. Everything, the services that we were talking about in the last slide, everything talks to each other via this thing called Fiddle. Fuschia intermediary something, right? I don't remember the acronym, but it's Fiddle. And so basically, say you do a driver for like, I don't know, a fingerprint sensor. The driver will say, cool, I will accept some input and I'm going to give out some output. It's all containerized and that's it. So any service that wants to use that fingerprint driver can say, oh yeah, there's a Fiddle definition for it. So I'm going to hook into that protocol and I'm going to send it what it needs and I'm going to receive what it needs. It's well defined. So you're not going to suddenly get something that you're not expecting, and it's secure. So you can't just like, the application can't talk to you or steal something from you, and you can't steal something from this application. They're all containerized. Now, one of the more interesting things about this is this idea of a package server. Think about, Fuschia. In one of the presentations I was watching, it's a really good presentation. It's an episode of Rubber Duck Engineering. We talk about that Fuschia is kind of thought out as, what would an operating system that follows the principles of a web browser look like? And that's kind of a loaded statement. I'm probably saying it wrong. But when you go to, say you open up your computer and you have nothing installed except for Chrome. Then you type in Facebook. Then you see Facebook doesn't work. So you go somewhere else and you type in google.com. When you go to google.com, your browser had no knowledge about how to render Google, not render Google, what Google has. It has no knowledge of anything. But what it does is it somehow grabs all that information from google.com and it's able to render it on the screen. And now you have this information that never existed on your computer. So this idea is brought to the operating system at a crazy level. When you are running Fuschia in development mode, so you're developing right now, if you type in, for example, ls, right, which is list all the files in this current directory, Fuschia will go, okay, let me go to, say, for example, user/bin, and it goes to ls. And it says, all right, ls, I'm going to run you. But it finds a file that says ls is not here, actually. ls is on https, not https, it's on Fuschia dev //fuschia.com/ls. It's like an npm repo somewhere where ls is running. And Fuschia goes, okay, cool. Let me cryptographically make sure it's secure. Whatever it does, it grabs ls and executes it. So what's very interesting is, imagine this was a driver you were developing, right? You could have this driver being pushed up to a package repo locally somewhere on your computer, and it's constantly pulling that driver and updating it as you're using it. Again, this idea of hot reload or hot restart happening on an application level. Now, obviously, this is not something you want in production. So in production, the package server will not obviously check whenever you run ls. It's going to check, say, every day, every 6 months, whatever frequency the device manufacturer or the user is configured. But that's something very interesting that a lot of operating systems are missing. I don't think any operating system has this level of updatability or package server. And that's, again, because Fuschia is designed with current context in mind. So with that, let me just move on here. I'm just getting rid of screens here. Okay, cool. So here's something that the Fuschia team directly says, and they have this on their website. We're designing the system so that Fuschia products can receive system updates without having to modify or recompile drivers. Drivers, system services, and end user applications would be updated independently through the same mechanism, reducing the maintenance burden. Device owners could receive Fuschia updates without having to update their drivers. Now, let me tell you a tangential story here regarding Fuschia and updates. Google Home Hub has been out for a couple of years now. It is a Google Home device, but with like a screen, right? One day, thousands or millions, however many people bought this device, woke up, looked at their Google Home Hub, and it looked identical. However, it was a whole different operating system. Overnight, it updated. It behaved exactly the same, but it was an entirely different operating system. This, to put into perspective, it's like waking up one day and using your Mac and then realizing that it's actually Windows under the hood, and you could not tell the difference. That is the wildness of the Fuschia team. That is like the audacity and the guts that they had, where they said, we could pull this off, and they did that. And that's proving how updatable Fuschia is, where you can actually swap an operating system, have Fuschia run, and because it's being designed with so many layers and modern operating system best practices in mind, it's able to perform this feat where you can just swap an operating system out and have Fuschia run, and it just works. Now, you might be going, well, something has to look different. The UI must have been different. They didn't copy it pixel by pixel. And this is where it gets really cool. And to the next slide, which is inclusivity, right? Fuschia is inclusive. it's built for our times, which means that it is not going to discriminate what language you want to use to program a Fuchsia app. If you like Flutter, build your application in Flutter. If you like Rust, build it in Rust. If you like Go, build it in Go, Python, Haskell, whatever the heck you want, you can build an application in that. Why? Because Fuchsia, again, is built with this containerization aspect in mind. It's built with everything it needs to run is packaged with the application. And so they have this idea of bring your own runtime. If you want to use .NET and you can get .NET runtime running in this, whatever Fuchsia ecosystem, build C# apps, right? It doesn't matter. So when we look at a Home Hub and what the Fuchsia team did, initially the Home Hub, the UI and everything was already designed running in Flutter, right? So all they had to do was make sure Flutter ran perfectly on Fuchsia. So when they swapped out the OS, Flutter was just running, right? So for Flutter, it was just like, oh, okay, cool. I guess I'm running now on Fuchsia instead of whatever operating system was running before on it. I assume it was some sort of like version of Android or Cast OS or something, right? So this is very interesting. You're able to actually design and build Fuchsia application using any programming language you want. So this will make it inclusive for developers absolutely everywhere. It's not going to be like, crap, now I got to learn how to use Flutter. No. If you like React Native, then build a whole React Native app and package it up, and it will run perfectly fine on Fuchsia. So this is again what the Fuchsia team said. Fuchsia simplifies the development model, making nearly all user space software a component, from system services to end user applications. This principle is known as bring your own runtime. I think it is fantastic, and I think it's going to open up a lot of doors as the operating system matures. Lastly, before we get into some demos, let's talk about what the last pillar, which is pragmatic. Fuchsia is not an experimental OS. Like I said, they just performed this like wild maneuver by replacing a running operating system overnight. You're sleeping and the entire thing updates to something else, and you as a user almost say there's a million people that had Home Hub. Assume only 100,000 of them were developers. 900,000 people have no idea that they're running Fuchsia OS, which is wild to me. It just replaced it. So it has real-world use cases already. It's already running in production, desktop deployment, and it's a real-time operating system built for high performance. So if you really think about, and again, I just want to make sure make it clear that I have no insight on their roadmap. In my opinion, what the Fuchsia team is going to do is probably one day replace this idea of Android Car and Android Auto running with Fuchsia. Again, the apps will run the same because bring your own runtime. Let's get Android running on Fuchsia, which they're already working on. If you look at the commits, then you'll just have the Android OS, the Android apps from Android Auto running on Fuchsia. Fuchsia's a real-time operating system. It will be a lot more stable running in a car and performing a lot more than just UI. It could possibly, power a self-driving car. And then the same thing with an Android device, right? Maybe Nexus 10 or Pixel 10 in 5 years or something. One day you're going to get an update for your Android 15 that will say, this is the last Android, and now we're replacing it with Fuchsia. For the end user, it's going to look identical. Everything will work. Android apps will work fine, but under the hood, it's not Android running anymore. It's actually Fuchsia. And so you'll be able to deploy more than just Android APKs. You'll be able to deploy React Native or Rust or Go or whatever apps because it's bring your own runtime. These are all just hypotheticals based on what I'm seeing in the code. I have no idea what they're actually going to do. So something that really stood out for me when I was reading the documentation was Fuchsia makes heavy use of asynchronous communication. The entire operating system is designed with async in mind. Again, keeping in mind the times that we're in, everything needs to be asynchronous. We can't just like assume that we have 1,000 CPUs running anymore. so which reduces latency by letting the sender proceed without waiting for a receiver. This is important for delivering software that can come and go on the device as needed to account for latency. This is wild, to come and go on the device as needed. You know, I did see in a presentation last year, and this could totally be out of the roadmap now, but they were talking about how applications, if they're not being used, can just go away, right? They're running on a package server anyways, but then when they need it, they can just pull it back. So lots of very interesting concepts when we're talking about Fuschia. Before we get into a demo of the emulator and a browsing of the source code, I just want to show you how the entire architecture of the operating system is right now. So you have at the top the user level, and then you have the product, the experience. So I guess that's the UI. And then you have runtime, right? That's where you can run Dart, web, Rust, whatever you want. You have a bunch of services, file system, because you could have multiple file systems. You know, Fuschia doesn't have one unified file system. Each different aspect of it has its own file system, right? Packages, all the blobs where they're stored. Then you have the drivers, and remember, these drivers could be hot reloaded, but everything on the screen, all the rectangles that you see are components. So all of them can be updated without interfering all the other ones, because they're talking through a well-defined, unified interface, and they're all containerized. So that's a really powerful thing, something that hasn't been seen. And I'm sure someone who knows operating systems a lot more than I do probably knows of an operating system that has kind of copied these concepts very early on, but never made it to mainstream because it was too early for its time. So with that, how do you actually get started in Fuschia? You can go to fuschia.dev and you can follow the instructions there. I have done this for you, so I went ahead. I'm going to share my screen here. Share screen, and I'm going to go to terminal here. Actually, what I'll do is I'll share my second desktop altogether. Cool. So, oh man. Okay, let's hope. There we go. It's working. Okay, so here is. I just want to make sure you guys can see this. 1 second. Stop screen sharing. Share. Yes, someone said, I cannot resist making an old guy comment. There were mainframe OSs before DOS. Absolutely, absolutely. My first operating system that I used was Windows 98, so I have no context into DOS. So I'm going to share my second screen here. I hope everyone can see it. So here we have, in this tab, we have the Fuschia emulator running. Like I said, it's not some fancy UI that you're seeing. This is actually just a simple emulator to run apps. But I want to show you how far Fuschia has gone. So what I'll do is I'll run this app called Simple Browser. And what it's doing, you see this thing spinning? It's actually gone ahead. I have a package server here that's running. So it went ahead to this package server and it said, hey, package server, I'm looking for a Simple Browser. And package server said, oh, yes, I have Simple Browser, the app that you need. I have it installed right here. Take it, right? So this happened because it's all running locally in near real time. And so now, oh, sorry, I'm getting a call. Weird. So now what I can do here is I can go, all right, let's go to google.com, right? And let's see if google.com works. And it renders it, right? Device is running slow, it's an emulator. But you know what? It rendered google.com pretty well. And here I'm on google.com, I'm going to search up, say, stock price of Facebook, just to kick the horse while it's down. Why not? And you can see, you know, the stock price fell. Facebook, it sent some user agent probably based on my screen resolution. And so it's running in mobile mode. But the thing is, it's running fine. In fact, I can go to youtube.com and I can actually play a video and the operating system will work. So this is just, I'm just trying to show you that Fuschia is not some experimental OS, right? It is ready for real time. It can run the modern web. Why? Because they just ported Chromium to it, right? Wherever Chromium runs, you'll get everything running here. And so I'm gonna run this video, whatever this is, I can't read it, Don Omar. I hope it is acceptable. But it'll probably won't even run fast because it's in my emulator, but it's going to render this video. You can see it's starting to render it. So Fuschia is pretty well advanced. Now, is it ready to like be installed on your desktop, ready to go? Absolutely not. There's so many things to do before that, just be me browsing the source code, but it's getting there, right? So let's put the emulator aside and let's actually look at how applications are even built in Fuschia. So I'm going to increase my screen resolution here. All right. So when you install Fuschia, and actually I'm going to kill this emulator and I'm going to show you where it's installed for me. Well, now it's lagging because I'm trying to run YouTube. Okay, cool. So here, all I have is I have the entire Fuschia tree checked out from the command that Fuschia talks about. And what I had to do was I had to do fx build. Fx is just the Fuschia execution tool, I guess. And when I do fx build, it will actually build the entire operating system the first time I run it. So run it on a fast machine. Don't run it on Apple Silicon. It will run on the older versions of MacBooks or Linux. It won't work on Windows. But when you run fx build, it's going to take 6 to 9 hours, and it will build the entire image. After that, it's just going to do an incremental build. So if I run it right now, you'll see that it's only going to build some files, probably because I was just browsing the repo and touching it. But it'll just build some small level of files and it'll be fine. Now, when you look at the operating system, actually, as you're trying to learn Fuschia and how applications are built, I would recommend you go into the examples folder and take a look at the hello world. Well, you can see here, it said no work to do. So there's nothing to compile because I didn't modify anything. So you can go into the hello world folder. And I like the hello world because it shows you how to build 3 types of apps. It shows you how to build a C++ app, a Dart app, and a Rust app. And these are all command line tool apps, so you're not going to get a GUI out of them. If you want to look at GUI, then take a look at, there's a Flutter app somewhere in this repo. I can't find it right now. But I'm going to click Rust. And for the people that like Rust, this will be very easy. It's just a simple Rust app. It runs main, right? And it prints a greeting and it prints another greeting. So it's going to print this function called greeting, which is returning a string created from these characters, right? Hello world, done. Now, that's really all there is. There is a meta folder, which basically tells Fuschia, hey, this is a binary app. You know, Rust doesn't have its own runtime, right? Rust is just, compiling on bare metal. So it's saying, use the ELF runner for this executable, which is going to be in bin/hello world Rust. Cool, fantastic. The same thing for C++. You look at a C++ app, and it's just going to be like standard out, hello world. That's it. You look at meta, and it's saying, cool, use the same thing. Use the ELF runner, bin/hello world C++. Now, if you look at Dart, which needs a virtual machine to run and all that stuff, that's where it gets very interesting. It's saying run this data called data/hello world Dart, and it has this entire GN file. I'm not sure what the G stands for, but N stands for Ninja. And this is basically like a manifest telling Fuschia how this application runs. Where's the source directory? This is a Dart library. Here's what it depends on. It depends on the SDK, Fuschia, the Zircon SDK, all sorts of configuration stuff. And you can read all this on the Fuschia docs. They're very well defined. But outside of that, when you go into lib and main.dart, it's just a boring old Dart app. There isn't anything fancy that's happening here, right? The only fanciness that's happening here is it's doing fuschia.exit, which is probably going to call some sort of like internally, some sort of exit command to tell Fuschia that the application is done running. So that is, in a nutshell, how applications at the most hello world level are running. The example has tons of little examples. Here's a Fortune app of how Fortune runs on Fuchsia. And you can just go ahead and see how how the Fuchsia team has built out all these example apps, and you can start to build your own application for it. Keep in mind that if you build an application for it right now, it's purely for hobby reasons. There is no, unless you're someone working with the Google team, getting Fuchsia running on a car, for example, or an IoT device, there's no real reason for a normal developer, not normal developer, it's not like they're abnormal, but like a regular developer who's building B2C apps to use Fuchsia right now. However, I think it's very important that everyone kind of check out Fuchsia. I'm just going to share my slides and just end this off here. Share. I think it's just very important for everyone to check out Fuchsia if they're interested and kind of understand how the operating system works. Because one of the things, and if there's any junior developers in the crowd or even senior, one of the things that really helped me out in my early career when Android came out was I started to look at Android from the OS level as soon as I heard like a device was releasing soon, or in a year a device is going to come out, because I wanted to understand how does the operating system even work. And so when I started building my applications, even though I'm not interfacing with the operating system directly, I'm doing it through a bunch of APIs. I kind of have an idea of how to build better Android apps, how to take advantage of the hardware and software, because I know how the operating system works. So with that, here's a good quote that I like using. We have not succeeded in answering all our problems. The answers we found only serve to raise a whole set of new questions. In some ways, we feel we are as confused as ever, but we believe that we are confused on a higher level and about more important things. So I hope my talk, has enlightened you a bit. You understand where Fuchsia is coming from, and it empowers you to go and learn more about Fuchsia. So with that, thank you. If you want to follow me on Twitter, it's Faisal Abid. And if you want to add me on LinkedIn, it's linkedin.com/Faisal Abid. Thank you. And so I'll leave the room open to questions. There is a Q&A here. Yes, so the first question is by Linda, and they ask, in the future, can a package server be tuned by running multiple instances of most heavily used components? I don't have an answer to it directly, but I don't see why not. I would have to look into how the package server is actually running, but you can assume for sure if Fuchsia, because Fuchsia is thinking about scale, that they are for sure thinking about how to optimize package server and take advantage of, the heavily used components and cache them or whatever. But I'm sure that's on the roadmap. Actually, if you go to fuchsia.dev, the roadmap's very clear. It's very transparent what they're doing, right? It's not transparent from a business standpoint because that's just their corporation. They're not going to tell the world their secrets. But from tweet him and he'll answer a question for you. That's how I learned about Little Kernel actually, before I even looked at the documentation. So I recommend, if you're interested in the future, join their Discord and start interacting with the engineers there. I always find that the Flutter team and the Fuchsia team, I think probably, and the Go team are probably one of the most nicest people working at Google. So they're very open to just answering questions. Any other questions? Cool. No questions. Give it another minute. I mean, in general, one of the misconceptions very early on was Fuchsia. Why is it spelled that way? I don't have no idea why it's spelled that way. I hate the spelling. I can never spell it. I always, whenever I type, I'm sure in my presentation I spelled Fuchsia wrong multiple times. And I'm sure that's not going to be the name of the operating system. If I had to make two guesses, guess number one is that eventually it's going to be called like Android X or something to do with Android, because Android is such a heavy duty brand name that I don't think they're going to throw away Android. It might be like, I don't know, Android. I think they'll just call it like Android 20 and it'll just be that, right? Or they will call it something else, but it'll be something that is a lot more easier to understand and spell. Even for as an English speaker, Fuschia is so hard for me to spell. Thanks, Tom. And so, like I was saying, please check out fuschia.dev. Lots of good documentation there. And I hope you learn something about Fuschia, you learn something about operating systems, maybe make a pull request, or just wait it out for a year or two. And if Fuschia becomes something that developers are investing time in, you'll know that you have a 2-year head start of just kind of understanding the patterns where Fuschia is coming up, so you can just jump in and start working. Thank you, Mark. And with that, if no one has any questions, I think we can end it off there, and I'll give you guys 15 minutes back. Cool. All right. Thank you. I don't know if I just close the Zoom, so I won't. I'm just going to like turn off my video and I'll let the host jump back in.